Good day everyone, welcome back to my channel. Today we will discuss the topic about the introduction to soil taxonomy. When you say soil taxonomy, it refers to the system of classification developed by the USDA or the United States Department of Agriculture Soil Survey. Soil taxonomy has three basic guidelines. The first one is classify soils on basis of properties. The second one is that the soil properties should be readily observable and/or measurable. For the third one, soil properties should either affect soil genesis or result from soil genesis. Why is soil classification important? It's because of the following reasons. First, that is to have an organized knowledge about soils. If you have an organized knowledge to have soils, the second reason is you will have an understanding on the relationships among the different soils. And when you have number one and number two, you can establish groups or classes of soils for management purposes, such as predicting soil behavior, identifying best uses, estimating productivity, and extending research results. There are 8 levels of soil classification. We have the order, suborder, grade group, subgroup, family, series, soil type, and soil phase. So in this table, you can see all the 8 levels of classification and the nature of differentiating characteristics. The soil order is the highest level of classification. And soil forming processes, as indicated by presence or absence of major diagnostic horizons, are the basis of characterizing the 12 different soil orders. Later on, as we proceed in this discussion, we will discuss one by one all those 12 soil orders. While suborder is the subdivision of soil order based on moisture and temperature regime. So later on, we will also discuss the different suborders under the 12 soil orders. Grade group is the subdivision of suborder based on differences, arrangement, and degree of expression between soil horizons. Under the grade group, we have the subgroup. It is typic or the central concept of the grade group. Intergrades or transitional forms to other orders, suborders, or grade groups. It could have extra grades or additional properties not common to grade group characteristics. Family. The nature of differentiating characteristic of family is that the properties important for plant root coat, broad soil texture classes, average over contrast section or solum, and mineralogical classes for dominant mineralogy of solum, and soil temperature classes are those factors that are being considered in differentiating the characteristics of family. For series is a class of soils and the basic units used to classify soils. There are nearly 400 soil series in the Philippines. The parent material, such as the kind, number, and arrangement of horizons in the profile, the kind and arrangement of horizons, color, texture, structure, consistence, and the action of horizons, chemical and mineralogical properties of the horizons are being considered in classifying different soil series. For soil type, it is the subdivision of the soil series based on the texture of the surface soil. It is no longer considered as a taxonomic unit. It is now considered as a phase. Soil phase is used as a subdivision of any class in the natural system of soil classification, that is, to indicate characteristics useful to management. So let's proceed now in discussing the 12 different soil orders. By the way, In this discussion, we will only focus on discussing the different orders, the 12 orders, and under the soil orders, we will discuss the suborders. The 12 different soil orders are the following. We have antisol, insaptisol, aridisol, salisol, mollisol, andisol, spodosol, alfisol, otisol, oxisol, vertisol, and histosol. So let's discuss all of them. We have antisol as the first soil order. It has the formative element and coming from the word recent. Antisols are very young soils showing very limited profile development and characteristically has the transitional horizons of A/C or A/R horizons or layers. So meaning you only have the topsoil and the parent material or the topsoil and the bedrock. Antisols exhibit only ephemeral soil development and are largely confined to surface horizons. Antisol may have an AP horizon, meaning a topsoil that is being plowed, regularly, and comprises 12.5% of world soils. So an example of antisoil is in this photo. It is an antisol found in Barrio Bugco municipality of Mondragon, Northern Samar, Philippines. The next soil order we have is the insaptisol. It has the formative element "ept", comes from the word inception. It refers to young soils with moderate profile development and shows the beginning of horizon development. There is little or no elevation, and the soil formed from colluvial material. So, an example of an inceptisol is in this figure. This one is an inceptisol found in Mogpog, Oriental Mindoro. As you can see, it shows the beginning of horizon development. And the difference between antisol and inceptisol, you can clearly see the margins between the A and the C horizon, or whatever horizon is present. Next we have is the aridisol. Aridisol has a formative element "id" from the Latin word aridus, meaning dry. It has limited change in parent material due to dryness, and it is commonly found in the arid regions of the world, about 19% of the world, with less than 10 inches of rainfall and usually contain carbonates. This one is an example of aridisol found in Nevada, US. We don't have aridisol here in the Philippines. The next one we have is the jelly salt. It has the formative element L, and this refers to young soils with little profile development, with presence of permafrost layer, and remains at temperatures below 0 degrees Celsius for greater than 2 consecutive years. It comprises 8.6% of the world's soils. So, a common example of jelly soil is found in Alaska. We don't have a jelly soil here in the Philippines. Next one we have is the mollisol. It has the formative element "ol" from the Latin word mollis, that means soft. This refers to soils with thick, dark, soft surface and are commonly found in the grasslands. Example of mollisol is found in Tagaytay, Cavite, Philippines. We also have andesol. It has the formative element and with no meaning. This refers to soils with volcanic ash and cinders with very light, low bulk density and early stage secondary minerals such as allophane, immogolite, ferrihydrite clays, and these soils are high in P fixation capacity or phosphorus fixation capacity. And andesol comprises 0.7% of the world's soils. This one is an andesol found in Camiguin Island, Philippines. Next one is spodosol. It has a formative element odd from the Greek word spodos, meaning wood ash. This refers to acidic sandy soils with thick E horizon, an albic or grayish horizon above a BHS horizon, or a spodic or alluvial accumulation of organic matter. As a subsoil has accumulation of iron and aluminum oxides, humus, and amorphous clay. This one is a spodosol found in Loreto, Peru, Southern America. Next is alphisol. It has the formative element alph, and this refers to soils with a geolic B horizon and high base saturation, and they are commonly found in fertile forested soils with ochric and argillic horizons. By the way, argillic means it is a subsurface B soil horizon that is identified by the alluvial accumulation of silicate clays, while ochric is a light-colored mineral horizon. Argillic and ochric are both diagnostic horizons. Next is ultisol. It has a formative element ult from the Latin word ultimus, meaning last. This refers to soil with B horizon that has high amount of soft clay but has low base saturation and are more weathered than alphisols. They are usually acidic in nature. Our next soil order is oxysol. It has a formative element ox from the word oxide. This refers to soils that are highly weathered with B horizon containing mainly 1:1 kaolinite clays. An example of oxysol is found in Salcedo, Eastern Samar in the Philippines. The next one we have is the vertisol. That's the formative element earth from the Latin word verto, meaning to turn. This refers to soils that show large cracks upon drying due to dominance of Montmorillonite. We all know that Montmorillonite or Montmorillonitic clays are prone to shrinking and swelling. Our last soil order is histosol. It has the formative element ist from the Greek word histos that means tissue. This refers to organic soils, such as peat soils, or those soils with high inorganic material. In this example, we have the histosol that is found in Dolongan, Western Samar in the Philippines. Now let us discuss the different suborders under the 12 orders. In this triangle, you can find the different suborders of antisol. And emphasis is divided between the permanent inundation by water, that is the wasants, subaqueous soils, near surface saturation, which is the aquens, the wet soils, those having sandy texture, such as the cements, those whose formation is in recent stratified alluvial sediments, those are fluvents, and a virtual lack of horizon formation, mostly in areas of young erosional surfaces such as the orthents. And we also have the arents, which have which have disruptive horizons. For the suborders of Insectisol, we have the following. The aqueps, which has a water table at or near the surface for much of the year. Next we have is the gelips. Gelips is common in very cold climates with an annual mean temperature of less than 0 degrees Celsius. For the cryops, these soils are common also in cold climates with an annual temperature between less than 0 degrees Celsius to 8 degrees Celsius. And then we have the steppes. These soils are common in semi-arid and subhumid climates. Next are the syrups. The soils are common in temperate with very dry summer and moist winter climate. For the UDEPs, these are common in areas with humid climates. And then we have the anthraps, which contain markers of past agricultural or past cultural habitats and anthropogenic or man-made activities. And these anthraps can occur in any climate. Aridisols have 7 suborders, namely cryades, which have a cryotic salt temperature regime, salids having a salic horizon within 100 centimeters of the soil surface, durids. These are soils that have a durapan within 100 centimeters of the soil surface. Gypsids are those that are having a gypsic or a petrogypsic horizon within 100 centimeters of the soil surface and do not have a petrocalcic horizon overlying the horizons. For the argids, these are soils that have argidic or natic horizon and do not have a petrocalcic horizon within 100 centimeters of the soil surface. Calcids are soils having calcic or petrocalcic horizon within 100 centimeters of the soil surface. And last but not the least are the cambids. These are soils that do not have the diagnostic properties defining the other suborders. For the jelly soils, this soil order has only 3 suborders, which are the following. Histels, those are organic soils, similar to histosol, but 80% or more organic material from the soil surface to a depth of 50 centimeter layer or solid layer is found. Turbels is found over one-third horizons are broken or distorted due to cryoturbation, and maybe ice wedges are also common. For all ortels, compared to turbels and histels, it is dry compared to histels and turbels and has little to no cryoturbation. By the way, cryoturbation means mixing of materials from various horizons of the soil down to the bedrock due to freezing and thawing. Next we have are the suborders of mollusol. And we have 8 suborders for mollusol. Aquols are those soils that are wet, meaning wet mollusol. Albos, these are mollusols having albic horizons. Rendols, these are soils found in humid regions that formed in highly calcareous parent materials such as limestone, chalk, and drift that is composed of mainly limestone or shell bars. You also have the gelos. These are soils found in cold regions. For cryos, these are deep, freely drained, with a correct temperature regime moldy soil. Xerols are those soils having a xeric soil moisture regime. Woodstones are those that are freely drained and commonly found in semi-arid to subhumid climates with austic soil moisture regime. And last but not the least is or the Udos. These are soils that are more or less freely drained and are commonly found in humid regions. The next are the suborders of andesol. There are 8 suborders of andesol. First we have is the aquand or aquants. Aquants have a histich epipedon or have aqueous conditions in a layer at a depth of 40 to 50 centimeters below the mineral soil or from the top of an organic layer. For the cryants, cryants are those soils that have cryotic soil temperature regimes. For gellands, these are soils that having a gelic soil temperature regime, meaning the mean annual soil temperature is less than 0 degrees Celsius. Under the suborder of andesol is the torrent or the torrents. Torrents have a acidic soil moisture regime. Stands. These soils occur in tropical regions that have austic moisture regime characterized by extended dry periods. Udans have humid climate and a relatively high content of water, held too tightly for plants to use. And wetlands, those are soils that are well drained, that are coarse textured, and are dominated by glass. And last but not the least are the serrans. These soils are found in warm and those areas having dry summer and cool and moist winters. Next we have are the suborders of spodosol. For the aquads are spodosols having aqueous conditions within 50 centimeters of the mineral soil surface in most years and have a histich epipedon or redoxymorphic features in the upper 50 centimeters. We also have the gelodes. These are soils that are better drained and have gelic soil temperature regime and are common in areas with high latitudes and altitudes. And then we have the cryodes. These are soils having cryic soil temperature regimes and are common in lower at altitudes and latitudes than the geodes. And then humods. These are not as poorly drained as aquads and have spodic horizons containing 6% or more organic carbon. And then we have the orthods, the last one. These are soils that are better drained with spodic horizon containing less than 6% carbon. For the alpha soils, we have 5 suborders. First, we have the aqualps. Aqualps have aqueous conditions for some time in most years within 50 centimeters of the mineral soil surface, have redoxymorphic features, and usually occupying depressional areas or low gradient landscape subject to seasonal inundation or high water tables. And then for cryalps, these soils have cryic or isofrigid, meaning the annual temperature is less than 8 degrees Celsius, isofrigid or cryic temperature regime.
And we have oostopes. Oostopes have, from name itself, have eustic soil moisture regime, meaning the soil moisture is limited but available during the portions of the growing season. Then we have the setup. So from the name itself, it has or it those soils have steric soil moisture regime, meaning it is moist and cool in winter and warm and dry in summer. And then the UDOPs, last but not the least, UDOPs are those soils having well-distributed rainfall, but not as wet as the aqualps, nor as cold as the cryalps, and have unique soil moisture regime. By the way, UDIC means the soil have enough rain or the area have enough rain in summer so that the amount of storm moisture plus rainfall is just equal to or exceeds the amount of evapotranspiration. And isofrigid, it means that the area where the soil has mean annual soil temperature of greater than 0 degrees Celsius but less than 8 degrees Celsius, with a difference between mean summer and mean winter soil temperature of less than 5 degrees Celsius at 50 centimeters below the surface, and warm summer temperatures. So on with the suborders of ultisols. Ultisols have one, two, three, four, five suborders. First are the aquates. So aquates are saturated with water at some period during a normal year or are artificially drained. Aquates have redoxymorphic features in all layers below 25 centimeters or any epihorizon present. And then we have the humots. From the name itself, humots have high organic carbon contents but do not have characteristics of wetness specified in the aquates. So humots contain more than 0.9% organic carbon in the upper 15 centimeters of the argillic or candleic horizon. Then you have the udots. Udots have periodic soil moisture regime, or it can be also unique soil moisture regime. By the way, periodic means there is extremely wet moisture regime. The dry periods of these soils are of short duration and organic carbon contents are lower than the humus. And then we have the ostots. So the soils have soil moisture regime that is ostic. Moisture is seasonally available in adequate amounts for at least one crop per year. And then the cerots. Cerots are common in areas of extremely dry summers and moist winters. And then we have the suborders of oxysols. For aquox, these are oxysols with water table at or near the surface for much of the year. And then the torox, these are common in arid climates. Ustox are common in semi-arid and subhumid climates. Ulox are common in humid climates. And ferox are common in continuously humid climates where precipitation exceeds evapotranspiration year-round. And then we have the suborders of vertisols. Again, we have the aquarts with aqueous conditions for some time in most years and have presence of redoxymorphic features. And then the cryots having cryc soil temperature regime. The ceroids. These soils have thermic, mesic, are frigid soil temperature regime, and islands irrigated have cracks that are open at least 60 consecutive days during summer, but are closed at least 60 consecutive days during winter. And then we have torts. So torts, unless irrigated, have cracks that are closed for less than 60 consecutive days when the soil temperature at 50 centimeters is above 8 degrees Celsius. And then we have the oysters. Oysters, again, unless irrigated, have cracks that are open for at least 90 cumulative days per year. And then the uterts, these soils have cracks that are open less than 90 cumulative days per year and less than 60 consecutive days during summer. So if you can note these, the suborders of vertisols are differentiated based on the period of when the cracks are open. Could be 90 or 60 cumulative days per year. And last but not the least are the suborders of histosols. Folists are soils that are more or less freely drained and that consist of horizons derived from leaf litter, twigs, and branches resting on bedrock or on fragmental materials. And then fibrous. So this soil contains wet and slightly decomposed organic materials. For the hemis, these are composed of wet and moderately decomposed organic materials. And then we have the saprist. Saprist are subaqueous soils and have a positive, that is wasis. Wasis have subaqueous soil and have a positive water potential at the soil surface for 90% of each day. So wasis is the only subaqueous soil in these five suborders of histosol. And then comparing saprist with hemis and fibrist from the word sapric meaning highly decomposed. Saprist are wet soils and contain well decomposed organic materials. So that's it. Thanks again for watching and I hope you learned from this video. Don't forget to like and subscribe.